Assalamualaikum, my dear fellows. Today we shall talk about the oxidations of polyhydroxy compounds using periodic acid. Polyhydroxy compounds. What are the polyhydroxy compounds? Those compounds which contain more than one hydroxy group. For example, cyclohexane 1,2-diol. It has more than one hydroxyl groups, so we may call it polyhydroxy compound. This is a one type of polyhydroxy compound. I'm writing the structures of a very important polyhydroxy compound, that is glucose. So it has more than one hydroxyl groups attached to the chain. So this is another example of the polyhydroxy compounds. So when these polyhydroxy compounds react with periodic acid. So what is periodic acid? You should be familiar with the periodic acid HIO4. So whenever you react with sodium periodate in acid, so you finally you get the periodic acid HIO4, periodic acid. Now what is the structure of periodic acid? Iodine, it can make 7 bonds four oxygen atoms are there and one hydrogen. So this is the structure of Lewis structure. I am drawing here its Lewis structure. Lewis structure of periodic acid. So what happens in this reaction when polyhydroxy compounds where two hydroxyl groups are vicinal to each other, or you may say that diols, I may call it 1,2-diol, cyclohexane 1,2-diol. So this is the preliminary condition, the preliminary requisite that the polyhydroxy compounds should be diolic format. They should the two hydroxyl groups should be vicinal to each other. When they react with periodic acid, what happens? We get this compound. Here, actually, the cleavage of carbon-carbon double bond occurs, and each doubly bonded carbon changes into formyl group. Here you see that COH alcoholic group, now it has changed into a carbonyl group. Here also it has now changed into carbonyl group, and this periodic acid it changes into iodic acid. So the oxygen content has reduced in this compound. It means it has reduced. So definitely it would have oxidized the other compound. So cyclohexane 1,2-diol upon oxidation using periodic acid makes the hexane 1,6-diol or the carbonyl compound. I write another compound, then we will discuss the mechanism of this reaction. Upon reaction with periodic acid, now what will happen when this vicinal diol or 1,2-diol would react with periodic acid? What would be the compounds? We know that periodic acid actually cleaves or breaks this this single bond, the bond between the two adjacent carbon atoms that are containing the hydroxyl compound, the hydroxyl groups. So what will be the products? The product will be the we know that this alcohol functionality would change into a carbonyl functionality. Cleavage would occur, and here also. So we will get a ketone, then we get the benzophenone, acetophenone, and HIO3 iodic acid. So what happens in this reaction? This is called the 1,2 oxidative cleavage. This is first carbon, this is second carbon. So 1,2 oxidative cleavage, because we are providing the oxidizing condition. So the vicinal diols, upon reaction with periodic acid, the cleavage occurs and each alcoholic functionality changes into carbonyl functionality. Let's discuss the mechanism of this reaction, how this cleavage occurs. Let's start with the first compound, that is cyclohexane 1,2-diol. These two hydroxyl groups are vicinal to each other. Remember, if there would be any spacer, then there wouldn't be any reaction. For example, if you are going to react this compound with periodic acid, there would be no reaction. No reaction. Why? Because the two hydroxyl groups were not in the vicinal position. They were not on the adjacent carbons. So this is the preliminary requisite of this reaction, that the the compound should be diols. The two hydroxyl group should be on the vicinal carbon atoms. Now in the mechanism, what happens? We know that the iodine is attached to 4 highly electronegative element, so making it electron deficient. So what happens is oxygen attacks on this iodine and this bond moves over the oxygen. So we get first positive charge should be here, negative charge should be on this oxygen, which is here. You see what happens? The oxygen attacks on this iodine, which is electron deficient. This bond moves over the oxygen. Now oxygen is getting negative charge. We know that the oxygen bearing positive charge is unstable. So what happens? The proton shift occurs. This bond moves here on the oxygen to stabilize, to neutralize its positive charge, and hydrogen now is getting positive charge, and this oxygen now it has a negative charge. It will attack on this. So actually proton shift has occurred. Proton shift. So we get this. Since we have another hydroxyl group, it attacks on this iodine and this bond moves over here. You get this intermediate. Since this bond moves over oxygen, oxygen will get negative charge, and this oxygen will get positive charge because it is making the bond by diverting the pair of electron to iodine. What will happen in the next step? Since the oxygen bears the positive charge, it will definitely would need the pair of electron. So how does it get? It get by pulling this pair of electron towards itself, so making hydrogen very electron deficient, and this oxygen is negatively charged. So hydrogen shifts from this oxygen atom to this oxygen atom. So here we are getting second hydrogen shift. You will get 1 2 3 4 5 6 7. So what is this? This is called the periodate ester. Periodate ester. So in the first step, actually what happens when the vicinal diol reacts with periodic acid, you get periodate ester. The second step is very important, so I should draw on another page. What we got in the first step, we got this periodic ester. periodate ester. Periodate ester. In the next step, actually, this periodate ester structure, it ruptures. How? Let's see. This carbon-carbon single bond, it breaks. This bond moves over here, making carbon oxygen double bond. This bond moves over iodine, and this bond moves here. So this cyclic structure ruptures by breaking this carbon-carbon single bond, and this bond moves here, making carbon oxygen double bond. This bond moves over the iodine, and this bond moves over the oxygen, making another carbon oxygen double bond. So what you get this compound, that is dicarbonyl compound, and IO. This OH, carbon double bond, iodine double bond oxygen, and iodine double. So what is the structure of this compound? H3IO4. Now what is the oxidation state of iodine here? Let's calculate. -2 on the 1 oxygens, since we have 4 to the 8, -8, and +1 into 3, +3. So definitely there would be +5 oxidation state of iodine here. What was the oxidation state in the starting compound? You will see that here the iodine has 7 plus oxidation state. So it means that the iodic acid has now reduced and it has oxidized the other compound. So this is hexane 1,6 hexane diol. Dicarbonyl compounds are formed in this reaction. I repeat, so you may have the better understanding of this mechanism. In the first step, the 1,2-diol react with periodic acid, how I have already explained. So in the first step you get this periodate ester, and then this periodate ester, this cyclic structure, it ruptures. How? By cleaving the carbon-carbon single bond. This bond moves here, and this bond moves here, and this bond moves over here. So you get the dicarbonyl compound. This reaction, you have noticed that we consumed only 1 mole of periodic acid, and how many bonds did it rupture? How many bonds did it cleaved? It cleaved 1 carbon-carbon single bond. So if you have this polyhydroxy compound, that is known as glycerol, here we have 3 hydroxyl group that are vicinal to each other, no spacer is between them. So upon reaction with periodic acid, how many moles of periodic acid would be consumed? This is very important to remember here. In the first step you will see that this bond will rupture and it will consume 1 mole of periodic acid, and another mole of periodic acid would be consumed by for cleavage of this carbon-carbon single bond. Now, what are the products? When I will say that this CH2OH will be changed into formaldehyde, and this will change into formic acid, and the terminal again this terminal carbon would change into formaldehyde, probably you would not get any idea. So let's draw the mechanism again and understand this. Now I'm not writing the intermediates, I'm just writing the structure of the per iodate ester here. And you will see that what happens next, this cyclic per iodate ester, it ruptured, this cyclic ring got ruptured. How? By oxidative cleavage of carbon-carbon single bond. This bond moves here, this bond moves here, and this bond moves here. So what you get CH2O, and this compound alpha hydroxy ethanol. Whether the reaction would stop over here? No, because we have still alpha hydroxy 2 hydroxyl and the carbonyl group. They are now adjacent to each other. This is the beauty of this reaction, that still if there are alpha hydroxy carbonyl compound, the reaction would proceed further. Another molecule of periodic S is here. 1 2 3 4 5 6 7, yes, periodic acid. So what happens in the first step, that this attacks on this iodine, this bond moves over here, you get since this oxygen now bears positive charge, it's unstable, it will pull this pair of electron towards itself, and hydrogen would be released as a hydrogen ion. This hydrogen ion will be shifted from this oxygen to this. So hydrogen shift occurs, so you get this. 1 2 3 4 5 6 7. Now what happens in the next step, this lone pair of oxygen, it attacks here, and this bond moves here. This will now get positive charge. Since oxygen now bears positive charge and this oxygen is bearing negative charge, just hydrogen shift occurs. This bond moves here, releasing this hydrogen ion, which is captured by this oxide ion. So you get this. Here we have iodine in the center, double bond oxygen, and this. So you got another periodate ester. Now what will happen? This cyclic periodate, the second cycloperiodate, it will rupture. This cyclic ring will rupture. How we know that? These two carbon which were vicinal to each other, this bond will move here, this bond move will here, and this bond will move here. So you will get carbon double bond oxygen OH, CH2 double bond O, and IO double bond O, I double bond O, OH, HIO3, and one molecule of formic acid and one molecule of formaldehyde is formed. So you have noticed this. Our starting molecule was glycerol. When it reacted with periodic acid, how many moles of periodic acid got consumed? 2 moles. And how many carbon-carbon single bonds got cleaved? 2 bonds. This one and this one. And did you observe that the terminal methylene carbon, this part of the molecule, it has now changed into formaldehyde, and the central carbonyl carbon along with this part changes into formic acid. So if I write another compound, sorry, this is very popular compound. What is the name of this compound? Glyceraldehyde. This was glycerol, and if you will oxidize the first carbon, you will get the glyceraldehyde. And I'm saying you to please react it with 2 moles of periodic acid HIO4. What will be the product? So So you will see that the terminal methylene group, it will change into formaldehyde, and this will change into formic acid, and this would also change into formic acid. So you will get two molecules of formic acid, HC double OH, and one molecule of one mole of formaldehyde. These will be the product. So, dear students, this reaction is used to calculate the ring size of glucose. This is used to calculate the number of carbon atoms in a compound in carbohydrates. This reaction, that is the oxidation using periodic acid, the oxidation of the polyhydroxy compounds or the carbohydrates, this reaction can be used to calculate the number of carbon atoms. I'm writing here the structure of glucose, so you will see that. One, two, three, four, 5, and 6. What is the name of this compound? Polyhydroxy compound. This is known as glucose. So if I say you to react it with periodic acid, and you will have to tell me that how many moles of periodic acid would be consumed and what would be the products. So by drawing the mechanism step by step, making first the periodate ester, then make the cleavage, and you will see that when you will cleavage this bond, this terminal carbonyl, it will change into formic acid, and this will change into formyl group. Then you will react another molecule of periodic acid, you will get the periodate periodate ester of using these two vicinal hydroxy compound. Then cleavage would occur and you will get formic acid from this. So 1, 2, 3, 4, 5, you will get 5 molecules of the formic acid, and this, because this is the terminal methylene group, terminal methylene carbon, it will change into formaldehyde. So how many moles of this periodic acid will be consumed? 1, 2, 3, 4, 5. So you would need 5 moles of periodic acid. It will cleave 5 carbon atoms. So we know that for one carbon atom there are 2 oxygen atoms. If there are 2 bonds, then there would be 3 carbon atoms. And if there will be 1, 2, 3 bonds, then there will be 1, 2, 3, 4 carbon atoms will be there. So you are going to break 1, 2, 3, 4, 5 bonds. Then how many number of carbon atoms would be there? 6 carbon atoms. So this reaction previously was used to calculate the number of carbon atoms in the starting carbohydrates. So remember one thing, that the prerequisite of this reaction, that the starting compound must have the two hydroxyl group adjacent to each other, vicinal to each other, no matter whether this the configuration, whether this hydroxyl is on the right side and this is on the left side, it it would not disturb the reaction. They will react. So two hydroxyl group, either they are on the same side or the opposite side, it doesn't matter. It would react and the cleavage would occur. The terminal methylene, they are it changes into formaldehyde like this. This is a terminal methylene. And if there is already a carbonyl compound, so we know that if the alpha carbon has hydroxy group, it can react with periodic acid. So alpha hydroxy carbonyl compound also react with periodic acid. So formal group would change into formic acid. So similarly, turn by turn, you will get formic acid from here, 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 here. 5 molecules of formic acid and 1 molecule of formaldehyde. How many number of carbons were expected to be in the starting compound? 6. We know that the number of bonds, it depends how many number of bonds would have cleaved. So they will tell us the number of carbon atoms in the starting compound. So I'm writing a few problems for you. So solve it and then tell me the answers. I hope you would, by drawing the mechanism, by practicing it, you will get through these problems. You will solve them and please show me the answers. The first problem is this compound. In the first step, when bromine is reacted in the presence of sunlight, we get the compound A. Then we react it with alcoholic KOH. We get the compound B. And when it is reacted with KMnO4 in dilute cold conditions, dilute gases, you get C. And when the C reacts with periodic acid, 1 mole, remember, 1 mole, then you get compound G. So then you will have to tell me what are these compounds A, B, C and D. Another very important problem. Sorry, this hydrogen is not there. This is known as fructose, HIO4. Now you will have to tell me how many number of moles of the HIO4 would be consumed. What will be the products? A plus B plus C. What would be the products? How many moles of periodic acid would be consumed? And how many number of carbon atoms were in the starting compound? Number of carbon atoms in starting compound. Here you can easily calculate 1, 2, 3, 4, 5, 6, but when I will write the products here, you will have to tell me the structure of the starting compound. I will tell you the number of moles of this iodic acid that would be consumed. I will tell you the product. So students, this is very important reaction. You must practice the mechanism, and then you will have to understand that what could be the possible products. And if I will give you the products and I say you to write the structure of the starting command, so you must have an idea that how will you solve this problem. Then if I give you the starting compound, and then you will have to judge that how many number of moles of the periodic acid would be consumed for the oxidation during the oxidation of this compound, and what would be the products. Draw the mechanism and take the pictures and show me. So I am leaving for you these problems, solve them. If you have any query, then please ask me. Thank you so much.